So in this session, we will discuss about the force acting between two connected masses. Let us consider two masses, let's say m1. This is the mass m1 and there is another mass which is connected to mass m1, let's say m2, and they both are kept on a frictionless surface. Frictionless surface means there is no frictional force between the surface and the masses. Suppose I apply a force F1 or let's say F on the left side or on the mass m1, that is on the left hand side. Now first point here we have to notice both of these masses have same acceleration. That is, whatever be the acceleration of m1, that will be the acceleration of m2. Because both these masses are connected, we cannot say both these masses move with a different velocity. Clear? So first we have to find the acceleration. For that, let us consider these two masses as a single unit. Let's say that has some mass m, which is equal to m1 plus m2. I'm considering these two masses as a single mass. And I just applied a force F. Now we have acceleration. We have to find the acceleration. Let's say acceleration A. We know by Newton's law, the force acting on a body is mass into acceleration. So acceleration will be force divided by mass. Here implies A is equal to, we have force equal to F. The mass m is m1 plus m2. Clear? So this is the acceleration on the mass. Now we should consider the free body diagram of these two masses. First I am taking the mass, I am considering the mass m1. Let's say consider the free body diagram. FBD means free body diagram of mass m1. We know on the left hand side of the mass m1 we have applied this force F. Now here I'm drawing m2 also. Here listen carefully. See, so these two masses are connected. So when this mass, when on the application of this force F, this mass m1 gives an action to this mass m2. Let's say the action be F1. And by Newton's third law, this m2 gives back a reaction to the m1 with same magnitude. We know action and reaction have same magnitude, but they act in opposite direction. One point also, that is, this action-reaction pair does not cancel each other because they act on different bodies. Clear? So I'm just considering the free body diagram of mass m1. Again, by Newton's law, we have unbalanced force. Unbalanced force is equal to mass of the body into acceleration. Actually, this one is the same equation, F equal to ma. But we have this statement on the Newton's law, unbalanced force acting on a body is equal to mass of that body into acceleration. Clearly, both these masses have, as I said before, have same acceleration. Clear? So, the unbalanced force acting on m1 is equal to, we know this is F is on the right, or F is acting on the right, acting towards right, and F1 is acting towards left. So, the unbalanced force equal to F minus F1 equal to mass m1 into acceleration. Now, we need to find F1. So, F1 is equal to, take this m1a to the left and this F to the right. So simplifying, you get F is equal to, or let me write like this, F minus M1A is equal to F1. Take this to the left and this one to the right. Now we have F minus M1. Here, instead of A, you can put this value. So that is equal to F divided by M1 plus M2. Clear? Equal to F1. So F1 is equal to, you can multiply this F with M1 plus M2. I'm just putting a 1 in here so that you can cross multiply. So this is equal to F into M1 plus M2 minus M1F whole divided by M1 plus M2. Clear? So simplifying, you will get F1 is equal to M1 into F is M1F plus M2F minus M1F whole divided by M1 plus M2. Clearly, you can cancel this M1F. So the force acting between these two masses is equal to M2F divided by M1 plus M2. Clear? So let me write these two values on the right hand side. We have the acceleration A is equal to F divided by M1 plus M2, and the force acting between the masses, that is action reaction, which is equal to M2F divided by M1 plus M2. Clear? Now let's take an example. Let's take, we have two masses, that is a 4 kilogram mass and a 2 kilogram mass, which are connected to each other. They both are placed on a frictionless surface. Let's say a force of 12 Newton is applied on the left side. We know the acceleration using this formula, the total force F divided by sum of the masses M1 plus M2, which is equal to 12 divided by 4 plus 2. That is 12 divided by 6. Therefore, acceleration is equal to 2 meter per second square. Acceleration of these two connected mass is 2 meter per second square. Now we need to find the force acting between these two masses, that is F1 is acting towards right and there is an F1 reaction towards left. So F1 is equal to, we know the equation, M2F divided by M1 plus M2. Here M2 is equal to 2. Here we have M1 is 4 kilogram, M2 is 2 kilogram. Definitely the force F is 12 Newton. So 2 into 12 divided by 4 plus 2, which is 2 into 12 divided by 6. So that is equal to 4 Newton. Clear? So if you draw the free body diagram again, now you can put the values. That is for the mass M1, which is 4 kilogram mass. We have a force 12 Newton on the left hand side and a reaction of the second mass. We have F1 is equal to 4 Newton and the acceleration of the mass A equal to 2 meter per second square. Clear? What about the second mass? M2, which is equal to 2 kilogram. The force on the left is 4 Newton. and acceleration A is 2 meter per second square. Clear? So this is the way we find the acceleration and force between two connected masses. Now what if we have three masses connected to each other? Now let us derive an expression for the force acting between three masses. Let's just consider three masses placed on a smooth frictionless surface like this. Let's say this be M1, another mass M2, and another mass M3. Of the three masses, we have M1 a greater mass and M3 is the smallest mass among these. They are kept on this frictionless surface. I am applying a force F on the left hand side. Again, the first point is we have to find the acceleration. You have to find the acceleration A. For that, let us consider these three masses as a single unit. Let's say M is equal to M1 plus M2 plus M3, and I am giving a force F. So acceleration is equal to force divided by the total mass. Therefore, acceleration A is equal to force divided by M1 plus M2 plus M3. Clear? Now let us find the force acting between these two masses M1 and M2. For that, let us consider the free body diagram of M1. So this is our M1. On the left, we have this force F. Now let me draw M2 here. As we discussed before, there is an action on the mass M2 by this M1, which is F1. And this M2 will give a reaction to M1 of same magnitude F1. And we have all these masses have the same acceleration, A itself. We already discussed that since they are connected, they does not move with a different velocity. So all of them have same acceleration. Now we have, and before that, consider the free body diagram of mass M1. We have, by the Newton's law, unbalanced force is equal to mass into acceleration. So for the mass M1, the unbalanced force is F minus F1 is equal to M1 into acceleration. So F1 will be F minus M1A, implies F1 is equal to F, we know, you just write that as F itself, M1 into acceleration is F divided by M1 plus M2 plus M3. And now, like we did before, let's take the cross multiply this equation. So F1 is equal to, we have F into, if I put a 1 in here, then you can multiply F with M1 plus M2 plus M3. M1 plus M2 plus M3 minus M1F whole divided by M1 plus M2 plus M3. Multiplying this to here and 1 to this one. So simplifying, you will get F1 equal to, this is M1F plus m2f plus m3f minus m1f whole divided by m1 plus m2 plus m3. Definitely you can cancel this m1f. So the force F1 is equal to, you can take this F as common, so that m2 plus equation will be m2 plus m3 times F whole divided by m1 plus m2 plus m3. Clear? So this is the expression for the force acting between m1 and m2. That is the action reaction pair between m1 and m2. Let me write it here, otherwise we will forget it. We have acceleration A is equal to F divided by m1 plus m2 plus m3. We have F1 is equal to m2 plus m3 times F divided by m1 plus m2 plus m3. Okay, now let me erase this. Now let us consider these two masses m2 and m3. Oh, I already write it here. Let me draw this m2 again. This is m2. Here we have F1 and the acceleration here it is A. Now let me draw m3 here. We know this time m2 will give a action to this m3, which is F2, and this m3 gives back a reaction to m2, which is of same magnitude F2 itself, but in the opposite direction. Here also the acceleration is A itself. Now consider the free body diagram of m2. We have unbalanced force. Here the unbalanced force is F1 minus F2, which is equal to mass of this body m2 into acceleration. Clear? We found out the value of F1. Well, here we have to find F2. So F2 will be F1 minus, rearranging F1 minus m2a. So F2 is equal to, F1 is equal to m2 plus m3 times F by m1 plus m2 plus m3 minus m2 into A. We have A is equal to F divided by m1 plus m2 plus m3. Now if you look at this equation, the denominator remains the same, so that you can write it like this: m1 plus m2 plus m3. Now you have to subtract this numerator, that is, we have m2f plus m3f minus m2f. This m2f will cancel each other, so f2 is equal to m3f divided by m1 plus m2 plus m3. Clear? That is, the force acting between these two masses is equal to F2 equal to m3f by m1 plus m2 plus m3. Let me write that here. We have F2 is equal to m3f divided by m1 plus m2 plus m3. Clear? Now let us consider an example. This time we have three masses. Let's say we have three masses, a 4 kilogram mass, a 3 kilogram mass, and let's say a 2 kilogram mass. They are placed on a frictionless surface connected to each other and is given a force F equal to 80 Newton on the left hand side. Now first we have to find the acceleration of these masses. For that we have this equation, A is equal to F by m1 plus m2 plus m3. Let me write m1 is equal to 4 kilogram, m2 is equal to 3 kilogram, m3 is equal to 2 kg, and the force here is 80 Newton. Okay, so the acceleration, we have this equation, 18 divided by 4 plus 3 plus 2, which is equal to 18 by 9, that is equal to 2 meter per second square. So the acceleration of each mass is 2 meter per second square. Now first we have to find the force acting between these two masses, it is m1 and m3. F1 here, action reaction pair. For that we have this equation, F1 is equal to m2 plus m3f, that is 3 plus 2 times 18 divided by m1 plus m2 plus m3, which is equal to 5 into 18 divided by 9. Cancel this, you will get 10 Newton. So F1 equal to 10 Newton. Then you have to find the force between 3 kilogram, that is m2 and m3. Between here, F1 is between these two masses. For that you can take this equation, F2 is equal to, you have m3f, m3 is 2, 2 into F is 9, sorry, F is 18 divided by 4 plus 3 plus 2, which is equal to 2 into 18 by 9. Cancel this, you will get 2 into 2, 4 Newton. Clear? Now you can draw the free body diagram for 4 kilogram mass. 4 kilogram, here it will be 18 Newton. Towards the left, that is the reaction of m2, which is we already found out, it is F1, that is 10 Newton, and the acceleration A is equal to 2 meter per second square, and this is m1. So for the mass m2, that is our 3 kilogram. On the left hand side it is 10 Newton, that is F1. On the right hand side it is 4 Newton. Again the acceleration is towards right, which is equal to 2 meter per second square. And for the 2 kg mass, here it is 4 Newton. 4 Newton, this is m2, this is m3. Acceleration is same, which is equal to 2 meter per second square. Clear? So this is the way we approach the problems of connected masses. Clear?